What's up guys, I'm Dahl from Scorpion Power System, and today we're starting the build log of the new Extreme Flight 70cc Peregrine. This is an awesome new fantasy biplane from Extreme Flight, and of course we're going to be building it electric with the Scorpion Power System inside. So let's get started. The Peregrine kit was very well packaged. Everything arrived undamaged and in pristine condition. Upon first inspection, I can say that this kit is absolutely beautiful. The covering work on it is phenomenal, no wrinkles anywhere to be found. The paint work is very good, no excessive orange peel, no runs or drips. Overall, the quality and of the aesthetics looks really good. Some things that I note right off the bat: the control horns come pre-glued on all the surfaces, ailerons, elevator, and rudder, which is awesome. We've got the full set of hardware here, all of the mounts for the wings, the wheel pans, wheels, nice carbon fiber wing tubes and stab tubes, pre-built tail wheel assembly. The kit does come with a clear cowl, as I call it. This is useful when you're wanting to drill holes for your mufflers, but of course we won't need to do that because we're doing electric. Inside the fuse, it's using this carbon plated plywood, which looks really good and is very strong and very well made. The kit comes as well with wing bags and stab bags. One thing I can say I love right off the bat is the implementation of all the quick release latches. So the bottom wing, they have a nice extension on the mechanism, which makes it convenient. The top wing has a quick release to separate the two wings. The latch in the front, again, quick release, easy changing of batteries. Canopy, quick release to get it off. Stabs, quick release to get it off. Normally biplanes have the preconception that they're a pain in the butt to work on and do field assembly, but this one looks like it's going to be super convenient to work with at the flying field. I'll do a quick run through of what equipment I'm putting in the Peregrine. For the power system, of course I'm doing an electric build, but I had the choice of going with two different power systems, either a really powerful one or a really powerful one. So this is a 70cc plane, and at Scorpion we normally would use our A65-28 PNP combo. Comes with an equivalent motor for 60 to 70cc size planes running on a 24-inch prop. Normally I would use that power system, and I think it would be really good for this plane. But we have another power system that I've just been dying to try on a plane this size. We don't sell this setup as a PNP combo yet, but all of the components are available for purchase individually. So for the motor, I'm going to be using the Scorpion A7430 185 kV motor, which is equivalent to an 80 to 85cc engine, but it's with the size and weight of a standard 70cc electric motor. And we sell an appropriate cross mount, which matches the bolt hole pattern of a standard 60 to 70cc engine, and we have the standoff set, which spaces this engine at the appropriate lane. So this combo here should bolt up right to the front of the plane without any issues. For the ESC, I'm going to be using the brand new, this isn't even out on the market yet, this is a prototype, but the brand new Tribunus 3 14 cell 150 amp ESC. There's a brand new ESC coming out later this year, so I'm going to be testing it on this plane. For the propeller, I've got a Falcon 25.5 inch by 13 inch carbon electric prop. For the battery, I'm going to be using a 12S 5500 to 6000 milliamp. I actually have a custom made battery that is just a 12S 5500 milliamp brick. I want to start by using this just because it's so convenient to just have one battery to charge and fly. To hold in the battery, I've also got a set of the Scorpion Heavy Duty XL battery straps. These are a really nice battery strap we make. It's a single length of a polycord material with kind of a rubber stitching on it for an anti-slip effect. And then the Velcro is just sewn on top of the single piece of material with box X stitching and a metal buckle. This thing is very strong and will be very good at holding in my batteries on this plane. I have a 5-inch spinner at the recommendation of Extreme Flight. The servos, I'm going to be using some from Expert RC. Their latest and greatest servo is the MT1000, but as this is a smaller plane, I didn't need 1,000 ounce-inch of torque, so I'm using some of their more budget-friendly servos. On the two elevators and the rudder, I'm going to be using the Expert A1 servos. And on the 4 ailerons, I'm going to be using the Expert A1 Plus servos. These are very good servos, and I've got a bunch of extensions here. You follow the recommendations in the manual on the links. So I've got everything ready, and now it's time to start building. First thing I do on any build is all the gluing. So first up will be this center strut for the top wing. It mounts very easily. There's a nice long channel that it slides into, which keeps it straight up and down perfectly, and then it pushes down to a bottom plate, which aligns the incidence of it perfectly. So you can tell when it's fully seated, this radius matches to the top of the fuse. Now that I'm comfortable with where it should sit, take a little bit of sandpaper, scuff up the section that's going to be in the fuse. I'm going to mix up some 5-minute epoxy, put that all over the piece and inside the hole, and then pop this in, wipe away all the excess, and then let that dry. I used 5-minute epoxy, and I will say that it was a little bit tight on time. So if you like to take your time, definitely recommend 15-minute or 30-minute epoxy. Now let's move on to gluing the mounts for the outboard wing struts. Gluing the mounts for the wing struts looks pretty straightforward. Included in the kit, there's 4 pieces, 2 that are labeled upper and 2 that are labeled lower. The piece is keyed, so you can't get it wrong, and it just slides in perfectly. I'm going to first make sure all the pieces fit into their slots properly, make sure no modification is needed. When doing the dry run, I noticed that the top of this little slot came flush to the wing on 3 out of the 4 wings. One of the wings, the piece didn't seem to sit all the way inside. It was up just about 1 millimeter, not much. Upon inspecting, down in the base of that hole, there's a little bit of a glue blob, very hard to see, but I think that's what's keeping that piece up. So not a big deal. I'm just going to go ahead and shorten this piece just a little bit, just to make sure that that piece can fully seat so that our alignment is all in track. So just make sure you look out for that on your build. And once that's done, I'll mix up some glue and we'll get these puppies set in. Gluing the mounts for the wing struts was uneventful. I ended up using 4 batches of epoxy, just 1 batch of 5-minute per piece. That way I had enough time to do all the cleaning. I used the technique of my dad where I cut paper towels into little squares and soak them in rubbing alcohol. Makes it really easy just to grab a wipe and throw. That way you don't get it on your hands or back onto the wings. I've got all the gluing done. The center strut and the wing strut mounts are all glued in. Next will be servo installation. Let's get to it. Now that everything's glued, it's time for the servo installation. First thing to do is to run all the extensions. So I've got a piece of wire here and some string I'm going to use to fish the cables through. In the fuse there is a tube glued in. This will make running the wires easier and also support the wires during use. According to the manual, it should be a 24-inch extension for the rudder and 36-inch extensions for the elevators. What I did is just run a string down that pre-glued tube, and then I actually taped and tied all the wires together to that string, and then just pulled all 3 wires through at the same time. I do know that the hole is a little small for my servo, so I'm going to go ahead and just take a Dremel and knock out a little bit on the sides. The rudder servo goes with the spline towards the tail of the fuselage, so just note that. Mounting the servo, I'll use the same technique as always. Drill 4 small holes, screw in the screws, screw them out, then put a little bit of thin CA onto the threads to solidify them, then screw the bolt back in for final assembly. Mounting the elevator servos was pretty straightforward. The servo slot was a little small for my servo, so I had to take some hand tools to open up that slot a little bit. Really nice, the 4 holes for mounting the servos are pre-drilled already into that fiber-plated wood. The servo is not buried very deep inside the surface, so it's quite easy to work on. Just using finger length, you can get the wires around, you can get the bolts in, and overall it was a breeze. Mounting the servos in all 4 wings was dead easy. Just make sure you have a piece of wire or something that you can use to fish the wires through, and it's super simple. The servos go with the spline towards the leading edge of the wing, and it went super easily. The holes were a little small, so I still had to open them up with a hand file, but again, it took like 10 seconds per servo bay. Not a big deal. The holes come pre-drilled, and it goes into this fiber-plated wood. So again, I didn't put the thin CA into those threads because it's fiber, it's not wood, so I trust it a bit more. It's very strong. The expert servos that I'm using have quite a long servo lead, so I didn't actually even need to put a servo extension on the servo. The stock wire length is fine, and I have just a little bit exposed here at the base of the wing. What I want to do next is put the power system in, but the fuse keeps rocking around because it's rounded on the bottom. So I'm going to go ahead and take the opportunity to get the landing gear on and the tail wheel on. The landing gear mounts on very easily with 4 bolts. Just put a little Loctite on them and thread them in. Same for the tail wheel. There's 3 bolts that hold it on. They're pre-drilled with blind nuts installed on the inside. A bit of blue Loctite, tighten them up and you're good to go. Now it's time to mount the wheel cuffs. It's nice that this rubber edge protector comes pre-mounted from the factory. There is a direction, a left and a right, so just try them on. It's pretty obvious which one is correct. I'm gonna mount it, put a piece of tape where the wheel cuff sits, take it off, put a bit of silicone glue all the way around on the top and bottom, then put the wheel cuff back on, tape it into position, and let it dry. While the wheel cuffs are drying, I'm going to go ahead and start mounting the main wheels. This was my first time doing the wheel pans for the Extreme Flight planes, so I'm going to give a pretty detailed overview. Of course, the kit comes with the axles, the wheels, wheel pans. It also has these 2 parts. There's a metal part and a wood part. Now this is part of the support, the counter support for the wheel axle to support it to the wheel pan. This wood piece is on an angle, so you need to make sure you mount it with this set screw down and the wood this way. That's because this piece will tuck into here, and this part of the wheel pan is angled a little bit, so you need to make sure that this angled part is down to match. What we are going to do, put the wheel on, take some blue Loctite for this set screw. Another thing to note, on this axle, there's a flat spot. You need to align the position of the axle where the flat spot is directly down, because this piece needs to align to that flat spot. Now when I go to mount the wheel pant, it's a little bit of a press, like a tight fit, but this just quite easily stretches over. The slot where the nut go in was just a little bit too tight for the position of the nut on the axle. So I had to take my Dremel and just oblong that hole a little bit to make room. But after I did that, it went on. And I go ahead and put the bolt from the backside. There's a bit of space, don't worry. Just as you tighten these bolts, it will kind of pull the wheel pan in, which compresses the piece against this counter support and helps keep it really nice and tight. At this point, everything is aligned and perfect. I'm gonna flip the plane over. I'll put a little bit of glue on that piece to tie it to there, and then we should be good to go. One thing to note when mounting the landing gear, the landing gear can mount either way, either swept forward or swept back. Most planes sweep forward, but according to the designer, for the aesthetics of this plane, they're designed to sweep back. It's user preference, but I went ahead and mounted them swept back as they're designed to be. Now that we're up on the gear, I want to start mounting up the power system. As I said, I'm using the A7430 185 kV motor, and we sell an appropriate cross mount which matches the bolt hole spacing of the standard 60 to 70 cc gas engine. And as well, we sell the standoff kit, which comes with a number of different washers to match the spacing of the cowl. Do note that there's a ton of aluminum washers and then 4 steel washers. The steel washers are designed to go behind the firewall to help with the loading from pulling on the motor. On the firewall of this plane, it is pre-marked for a DA70cc engine, so I just need to drill out those holes. There is some triangle stock reinforcement which hits the standoff. I'll just take a Dremel and take out a little bit of this triangle stock to make room for the standoffs. Then I can mount the cowl onto the plane and start using the washers to position the engine where it needs to be on the plane and get that all taken care of. I ended up just having to use 2mm of washer to space the engine out 2mm, and now it lines up perfectly. On to mounting the ESC, the Tribunus 3 series have integrated mounting tabs, so it will be really easy to install this ESC. The ESC comes with standard metric mounting bolts, but also comes with some wood screws, which I'm going to use here. I can drill 4 small holes. The front 2 are going to go actually into the firewall, so it will be very strong and the bolts won't protrude through the back side. But the rear 2 bolts, it's just going to go through the bottom of the motor box and the screw will stick out. I'm just going to go ahead and do that, and then after everything is mounted, I'll use a Dremel to take off the exposed part of the threads so that it doesn't come through and puncture my batteries, for example. For connecting the phase wires, I'm just going to wrap the wires around the side and plug them into the motor. I'll use some of the black EVA foam that's included in the motor box packaging to protect those sharp carbon edges and to support everything. Then I'll use some Scorpion lock strap to hold everything all together and in place. My plan is to just tuck the battery wires around and right into the motor box. It should be right where my battery is, and will make for a very convenient wiring scheme. We've got the gluing done, the servos in, the power system mounted. About the only thing left to do is start to do my receiver installation, run some of the wires and extensions, and then we'll get into the control surface programming. I'll make up the linkages. I will post on the screen what are the approximate lengths of the linkages that I'm using for your reference. Of course, depending on which servo you are using, it might vary a little bit. But overall, I think this is going to be a pretty straightforward process. No need to highlight anything in particular here. If there's something of note, I will let you know. The ailerons, I'm using a 1.5-inch servo arm, and I have right now as a starting point about 36 degrees of travel up and down. Of course, I'll adjust that in flight as needed. On the elevators, I'm using a 2-inch arm, and I get about 60 degrees of travel up and down. On the rudder, I went to 1.75-inch servo arm, and it's maxed out as much as it can go. Of course, all that's going to tune in flight, but these are my starting values. Of course, I need to button up all the wires. I'll show you the final result on the screen once I'm all done, but I don't need to walk you through that process. Coming to the very end of the build, the last thing I need to do is focus a little bit on the cowl and the motor and ESC cooling. With any power system, one thing of paramount importance is cooling. The designer of this plane, Ben Fisher, who knows this, was smart enough to create some nice 3D CAD files of baffling that direct the air right towards the motor, and also a duct that goes right to the ESC. He sent me those files, which are also available to the public, and I went ahead and had them printed. I glued them in with a little bit of medium CA, and they work perfectly, and the function is great. The 2 on the front, right and left, those direct the front air and bend it around and aim it right at the motor from both sides, which help with motor cooling. And then the one on the ESC, it takes air right from the bottom, directs it up, and it blows it right over the ESC. There was a piece of wood on the front of the fuselage. I knocked that out, and I will cut a hole on the bottom of the fuselage to allow some of that air to flow past the ESC through the whole fuselage, help cool down my batteries a bit, and then exit the back of the fuselage. We are in the final stages. All I've got to do is mount my battery connectors, do the final wiring tie-ups, go ahead and mount my prop. For measuring the CG, what you want to do is have the plane completely ready to fly, but with the wings off. Then you pick it up by the wing tube hole on the center cabane. What we'll look for is if the plane is angled forward or completely level, it means it's too nose heavy. In contrast, if when you pick it up, the plane is angled excessively backwards, that means that it's too tail heavy. What we are looking for is that the plane is almost level but angled a little bit backwards. Then we know that the CG is at the starting point. Alright guys, so we are at the flying field and we're ready to maiden this beautiful plane. So for the CG, as I said, I'm using a bit heavier power system, so my battery is a little bit farther back. This is at the starting CG point recommended by the manufacturer. So we'll see where it ends up from there. Already gone over the plane, double checked all the quick release locks, all the surfaces are tight, directions are good, setup is right, and we should be good to go. The only thing I want to do last is I'm going to run the power system a bit on the ground just to make sure everything's working as it should, and then we'll get her in the air. just finished up the first flight. Wow, this plane is, I can tell it's going to be really fun. So the power system is running dead cool after that flight. It's not a super hot day, around 26 degrees centigrade, but the motor is dead cool. The ESC running at 40 degrees centigrade, super cool. That flight was over 6 minutes and the batteries still got a little bit of juice left in them. First impressions, it rolls beautifully, very axially. It has tons of knife edge authority, flies very crisp, straight and true, and just looks beautiful. As far as tuning, right now I'm still using max elevator and max rudder. On the ailerons though, I did note I had to turn them down quite a bit for normal flying. So this was my max rate before, around 36 degree. What I tuned there in flight was this. I don't know how many degrees it is yet, but this plane, I guess with 4 ailerons it doesn't take much to get it to roll fast, but it rolled really straight, really crisp and true for not much deflection. This concludes the build video of this Scorpion electric powered Extreme Flight Peregrine. Thank you guys for following along and watching. I hope you found it informative and interesting. I'm gonna go out and continue flying and tuning, and yeah, thank you guys for following along, and see you in the next build video.